All right, so you guys are at a little bit of a disadvantage actually because they taught this sort of concept in the old course, and so now they kind of just assume that you know it, which is a bit unfortunate because yeah, you haven't been taught it. But I'll give you a little rundown on what this concept is, and I'll show you how it applies to complex numbers, right? So basically, this is what we call this concept a locus, and basically a locus is describing the movement of a point along a path, right? So for example, you can describe a straight line essentially with your normal equations like y equals to x or something like that, right? But what we can also do is we can describe that a bit differently. We can take an algebraic approach to this, but as you've been seeing, we can also take like a graphical or geometrical kind of approach, right? So let's look at this example over here, right? Find the equation of the locus of a point P xy so that it is always 3 units from the origin. So like just before you jump into trying to do something algebraically, just think about it visually. Like where's a point that's 3 units from the origin, for example? Here's our origin here. 3, yes, very creative. Good, I like it. Where else? Are there any others that satisfy? Because this is 1, right? Yeah, 3i. Yeah, I wasn't actually going to get into complex numbers yet. I like the Argand plane. I was just going to look at the Cartesian plane first of all. Yeah. But we'll look at that in a second. Yeah. Let's just keep it like familiar first. So the Cartesian plane, because you can actually do it in both. And previously they would introduce it in the Cartesian plane, right? And then hopefully you're starting to see there's a lot of different points here that satisfy this, right? Are there any others beyond these 4 here is the question. Yeah. They form a circle. Good observation. So I'm going to try and draw a circle, but. Is it? Yeah, okay. And that's the end. That's the lesson. We're done. Thanks, Cameron. Not the best circle, obviously, but so that's like a very good geometrical approach. Can you see how just powerful that is? Just visualizing what's going on. You can solve this problem very easily. This is the equation. Center of the origin. So x squared plus y squared equals to 9, right? And this is going to be a way that we can approach these sort of locus problems by thinking about them geometrically or visually. But there will be some other difficult ones that we can't necessarily see visually, and we will have to do algebraically. Before we jump into that, though, I did want to show you something to do with circles. Does anyone know what these are? They are circles, yes. Man, Cameron's power of deduction is just next level today, right? What do they kind of look like to you? A field, yes, exactly right. Listen, it actually is a field, and in fact, these are crop circles. So if you go to places which use this system, and you take images from above, you'll actually see these kind of images here. There's these big circles here. If you actually go down to the ground level, you can see these little contraptions. I think it's called something crop water irrigation or something like that. There's some name for that, where they have these sort of machines that can create this particular pattern in the ground. And so this is essentially a locus, right? The locus is the distance always being 3 units from the origin. Oh, sorry, I remember it's called center pivot irrigation. And so basically there's this machine here which is fixed to a center, and it moves around and creates this circle here, right? So that's just an idea of what exactly a locus is. It's describing the movement along a path. But my suggestion was we can do this algebraically as well. When you think about distance, right, we have the distance formula, for example. So essentially, if you have a point P and you have the origin O, right, we essentially want PO to be equal to 3, right? But there's not too much we can do with that, right? We have a point 0, 0, and we have a point XY. Typically, when we want to find distances, we would use the distance formula, right? So PO, for example, well, what's PO? That would be, thinking about your Pythagoras theorem, that would be x minus 0 all squared plus y minus 0 all squared is equal to 3, right? Can you see how we might get to our equation of a circle from this? What do you think, Alyssa?
Well, you end up with x squared plus the square root of x squared plus y squared equals 3.
Good.
So then if you square the square root
nice.
of square 3.
Exactly right. So typically what we'll do is if we square both sides, we'll get to what we were expecting before. X squared plus y squared is equal to 9. And in general, it's more easy to consider, rather than going PO is equal to 3, it's easier to consider PO squared is equal to 9. You square both sides from the beginning, and that way you kind of have to, you skip this step here that you're involved, because you're almost always going to be doing that when you're trying to find this locus or trying to describe this locus here. Okay, you want to jot those down for me?